Hey everyone, today we are going to be talking about graphing your sine and cosine functions. All right, so there's pictures of what our sine and cosine graphs look like. And by the end of the lesson today, you're going to be able to graph both sine and cosine functions and identify the amplitude and the period. So let's get started here by just filling out this chart so we have some values to help us get started. Okay, so if I have an angle of 0 degrees or 0 pi, all right, well, we should know by now the cosine of that is 1, all right, and the sine of that is 0. For pi over 6, we normally say the cosine of pi over 6 is root 3 over 2. However, um, we're going to change that to a decimal so that we can actually um, figure out the value of it. So root 3 over 2 is 0.866. And then sine of pi over 6 is 1/2, which we know is 0.5. Cosine of pi over 4 is root 2 over 2, but again, we're going to change it to a decimal, and that's 0.707. And then it's going to be 0.707 also for sine. And then cosine of pi over 3 is 1/2, 0.5. But sine is root 3 over 2, which we know is 0.866. Cosine of pi over 2 is 0, and the sine is 1. Cosine of pi is -1, and the sine is 0. Cosine of 3 pi over 2 is 0, and then the sine is -1. So we're going to be using all of these values here in just a moment to build a graph, okay? So don't lose these values, kind of hang on to them off to the side. So when we graph sine and cosine functions, we're kind of just unwrapping the unit circle onto the x and y axis. All right, so our angle measurements, what I gave you on the left of that chart, are going to go on the x axis. All right, whereas your trig values, what we get out when we plug in those angle values, are going to go on the vertical y axis. All right, so now we're going to graph using those tables. So, all right. So y equals sine of x. So again, look at the table if you need to, and we'll even extend this out to negative pi over 2, but I'll do that second. So sine of 0 is 0. Okay, and then now pi over 6, pi over 4, pi over 3 are in here, and sine of pi over 6 is 1/2. Okay, sine of pi over 4 is like 0.7, sine of pi over 3 is like 0.8, or they'd probably be a little bit higher than this, it's a little skewed, but sine of pi over 2 is 1. So right here we kind of have a little curve, okay? So we have some curving action there. And then if we had continued our table, sine of 2 pi over 3, well, that's still in the second quadrant, so it's still positive 0.866, and then pi over 4, and then, or sorry, not pi over 4, but 5 or 3 pi over 4, and 5 pi over 6, and then at pi, we're back down to 0. So here's my first part of the curve, and then what's going to happen for the remainder, okay, at 3 pi over 2, we're at -1 for our sine value. At 2 pi, we're back to 0. And then we'll have all those values, but now they're negative since we're in that third and fourth quadrant, okay? So there's your picture of your sine. Now we could actually continue that and say, well, sine of negative pi over 2 is actually -1, all right? So it actually continues, and it's that pattern that we see there is going to keep going. So our domain is -infinity to +infinity, whereas our range is going to be from -1 to +1, because that's the highest we go and the lowest we go. So our cosine graph, all right, so again, we're referring back to that table, but we're going to see some of the same values that we saw before. All right, so we've got pi over 6, pi over 4, pi over 3. Okay, cosine of 0, though, is 1. Okay, And then cosine of pi over 6 is, or sorry, not pi over, yeah, cosine of pi over 6 is root 3 over 2. So that's that 0.866, and then 0.7, and half, and then 0. So now we're noticing our curve goes down. All right, and then we know at pi we're down at -1, 3 pi over 2 we're up to 0, and then 2 pi we're back at 1. And we have, that same type of curve, but it's actually shifted over pi over 2. So, so they look very similar, right? Slightly different. So the domain, again, is -infinity to +infinity, and the range is -1 to +1. So what if I asked you to sketch, just your normal sine curve, but I'm changing, the interval. So say we're at -pi, that's out here. So -pi over 2 is here, 0, then pi over 2, then pi, and then 3 pi over 2. Okay, so you could still start it off at 0, and say, well, I know that. This is -1, this is +1. So I go up to +1, down to 0, down to -1. I didn't go quite far enough. And then on my other side, it'll be down to 1 and then up to 0. So here is my curve, my sine curve on that interval. So whatever the interval is, we can change it. So now y equals cosine of x, we're going to go from -pi over 2, and actually this should say pi on your note sheet, so I'm going to change that. So -pi over 2, pi over 2, and pi. The cosine of 0 is 1. Cosine of -pi over 2 is 0. Pi over 2 is 0, and -1. All right, so then we have, just part of our cosine curve there. So there are more complicated sine and cosine functions that, the generic form of them is going to be y equals a sine of bx minus c plus d. For cosine, it's the exact same form, but instead of sine, we have cosine. My amplitude is the absolute value of a. So your a is this coefficient out in front of your trig function. So the absolute value tells you your amplitude, and that's going to give you kind of how you are vertically stretched or compressed. So the larger the absolute value, the steeper your graph is, the more stretched it'll be. The smaller it is, the more compressed it'll be. Your period always follows this formula, so you're going to want to have that written down. So to find the period, how long we are sketching for, we do 2 pi divided by the absolute value of b, and b is the coefficient of your x. Okay, so the value of b changes the period by stretching and shrinking the graph horizontally. So if you have a b value between 0 and 1, that period is going to be stretched, and if you have a b that's greater than 1, your period is going to shrink. And then we'll talk about horizontal shifts and vertical shifts later, but horizontal shifts are c over b, and vertical shifts are d. So let's do a few more examples. So y equals 2 cosine of 4x. So my amplitude is 2, and my period I'm going to find by doing 2 pi over 4, and that reduces to pi over 2. All right, so I'm going to put pi over 2 here, and we're just drawing one period of our graph. So half of pi over 2 is pi over 4, and half of pi over 4 is pi over 8. And then 3 pi over 8 is in between. We'll put -2 down here and +2 up here. Now, this is your cosine graph, so you should know that normally when our amplitude is 1, cosine starts at 1. Now that my amplitude is 2, it's going to actually start at 2. If you don't believe me, try it out, right? Cosine of 4 times 0, 4 times 0 is 0, cosine of 0 is 1, but 1 times 2 is 2. And then when we plug in pi over 8, we actually get 0. When we plug in pi over 4, we get -2. And we don't actually have to plug them in anymore because it's always going to follow this pattern. Okay, so there is my cosine graph. Now this graph says y equals -2 cosine of x over 2. So my amplitude is still 2, even though this is a negative, but the negative tells me I'm going to flip, okay? So instead of starting up at the top for cosine, we're going to end up starting down at the bottom. Now my period, my b value is 1/2. So 2 pi divided by 1/2, we keep change flip, that actually becomes 4 pi. So then we're going to mark off our little area here. Okay, and again, because it's flipped, we know we start at the bottom. Here, I'll change colors. And then we're going to go up to 0, up to 2, down to 0, down to -2. So that's our cosine graph flipped over. All right, let's do sine. So y equals 3 sine 4 pi x. So my amplitude is 3. My period, I do 2 pi divided by 4 pi. Sorry that moved. That's going to get me 1/2. All right, so 1/2 is here. Half of a half is 1/4. Half of a fourth is 1/8. And in between there is going to be 3 pi over 8. -3 to +3. Okay, it is my sine function, so I start at 0, 0. Okay, then I'm going to go up to 3, back down to 0, down to -3, and up to 0. So here is my sine graph. And then the last one on the notes here, my amplitude is 3/2, and my period is going to be 2 pi divided by pi. That gets me 2. So 2 goes here, then 1's in between, 1/2 and 3/2, and then -3/2 and +3/2. It's a sine graph, but it is negative, so we know we're going to flip. All right, so we'll still start at 0, but instead of going up, we're going to go down to that -3/2, up to 0, up to 3/2, down to 0. So there is the graph of sine, and that is how you graph sine and cosine function.